Hello everyone and welcome to another tutorial video. So in this video we'll be treating higher order derivatives. Okay, so initially we explain partial derivatives. Okay, so partial derivatives has a link, okay, has a connection to what higher order derivatives. So it's like they are intertwined, but higher order derivatives is a bit cumbersome. It might look a bit cumbersome, so you have to you have to understand the concept of partial derivatives before you could implement the concept into what higher order derivatives. Okay, so you'd have to understand the concept of partial derivatives, and then you just apply the concept when it comes to what higher order derivatives. So in case you are new to this channel, I would urge you to subscribe to the channel, turn on your bell notification so that you don't miss out on any future videos, and then in case you have any questions, just leave them in the comment section and then I'll reply to them as soon as possible. Okay, so right, so this is how this is the concept of higher order derivatives. Okay, so in case you are given what a certain derivative, okay, or a certain expression, okay, let's say the expression is z and then the expression has a function of x and y. Okay, so most of the times you have x and y, a function with x and y, okay, and then you are told to differentiate with respect to x, okay, and then sometimes differentiate with respect to y. But let me make the concept of higher order derivatives very simple before I get into the nitty-gritty concept. Okay, now higher order derivatives is all about partial derivatives. Okay, it's just like partial derivatives. Okay, so you are trying to differentiate one variable with respect to the other. Okay, so once the other doesn't have the variable you are trying to differentiate attached to it, it goes to zero. Okay, just like partial derivatives. But the one thing about higher order derivatives is that you are to differentiate a specific variable for a couple of times. Okay, so you take the first derivative, second, and then maybe sometimes you take the third. Okay, that's what higher order derivatives is all about. Okay, so you try to differentiate with respect to a specific variable for a couple of times. Okay, so that's the concept of higher order derivatives. Okay, now so let's go into the concept. Okay, so we have what z. So WRT is all about, it's a notation for respect to what, okay, with respect to. So z with respect to x is equal to what, partial derivative of z divided by a partial derivative of x. So note the difference between this one. Okay, note the difference between this and then that. This is what, partial derivative, and then this what, just differentiating. Okay, so this is partial derivative. Okay, and then this is when you are differentiating. Okay, so we have what, the partial derivative of z with respect to that of the partial derivative of x, and then that will be called what, you are trying to partially differentiate x with respect to z with respect to x. Okay, and then that gives us what, zx. So when, in case you know or if you watch a video on partial derivative, you would understand this what, notation. Okay, now let's proceed. So once you want to differentiate zx, okay, this zx with respect to x, this is how you just represent it. Okay, so the partial derivative divided by the partial derivative of x, and then you open brackets, have the derivative of z divided by what, the derivative of x. Okay, and then that will be equal to, you just multiply. Okay, you just multiply them, and then we have what, the partial derivative squared of z divided by the partial derivative x squared. Okay, this means that we are trying to differentiate, okay, the z by respect to x two times. Okay, we are trying to differentiate the expression z by respect to x two times. So it's something like the z on what, the x, but we are doing what, partial derivative. Okay, because we have what, y. Okay, because we have a certain y in the what, the expression z, that's why we have partial derivative. Okay, now let's look at the next one. Okay, this next point. So we have what, zx with respect to what, y. Okay, zx with respect to y. Okay, so y with respect to what, we are trying to take what is x with respect to y. Okay, which is equal to the partial derivative of what, that of the partial derivative of the z. Okay, and then we take what with respect to y. So we are in this concept we are trying to differentiate x, and then at the same time take the partial derivative of y. Okay, so after taking the partial derivative of x, you take the partial derivative of y. Okay, that's why we end up with this concept. Okay, or this notation. Now let's take the partial derivative of what? Y, okay, with respect to x, okay. So zy with respect to x is equal to the partial derivative of zy, and then with respect to the partial derivative of what? X. So in this concept, we are trying to differentiate or partially differentiate y. After that, we partially differentiate what? X. Okay. So this is what the notation will look like. Okay. So in case this sounded cumbersome, okay, don't worry. We are coming to dive right into simple questions so that you get to understand the entire concept. Okay. The examples will help you understand the concept in case this sounded cumbersome. So let's look at the examples. Okay. Now, so we've been given what? Z. Okay. So initially we knew that we will be given Z, which will be a function of x and what? Y. Okay. To be a function of x and y. Now we could see that Z is a function of x and y because we have what? 3x squared y cubed minus s exponent 4y squared minus 10y plus xy. Okay. Now we are told to find what? The first question is to find what? Z xx, and then second one z y, and then it continues like that. So let's take the first question. Okay, so for the first question, we are just trying to partially differentiate x. Okay, we are partially differentiating z, the function z with respect to x, 2 times. Okay, 2 times. That's why we have what? Zxs. Okay, so let's try look at the solution. So this is the main question. Okay, 3x squared y cubed minus what? X exponent 4 y squared, and then we have what? Minus 10 y plus what? Xy. Okay, so now let's see. We are taking what? Zx x. Okay, so we are to differentiate z with respect to x 2 times. So let's first take the what? The first derivative. Okay, we are taking the first zx. Okay, so let's do that. So when you differentiate the whole of this, you end up with what? 6xy cube. Okay, minus, when you differentiate this, you end up with what? 4s cube y squared. Okay, this doesn't have any x attached to it, so it goes to 0, and then this will have what? We will be left with what? Y over here. Okay, right. So now we've taken the first partial derivative, so let's take the second partial derivative. Okay, note we are differentiating 2 times. Okay, so now let's take the partial derivative of the second differentiation. Okay, so from here we have what? 6y cube. Okay, then we have what? Minus, this will give us what? 12x squared y squared. Okay, so this will be our what? Final answer. Okay, this will be our final answer for the first what? Question. Okay, so we tried partially differentiating 2 times. That's what? Zxx. Okay, and then we ended up with this. Okay, so now let's take the second question. So we have to partially differentiate z with respect to y 2 times. Okay, so let's first take the what? The first partial derivative of y. So we are taking into consideration the same question. Okay, this question, let me just keep that in a specific color so that we know what we are dealing with. Okay, so we have this is what we are trying to partially differentiate. Now we are trying to partially differentiate only y. Okay, so let's see how we go by that. So we have what? When you differentiate this with respect only y, you end up with 9, okay, x squared y squared, because 3 will come here. Okay, so 3 will multiply this 3, giving us 9. Okay, and then we end up with this one. Okay, so in case you watch our video on partial derivative, this will look simpler, but all you have to just keep in mind is that you are trying to differentiate or partially differentiate one variable more than once. Okay, so we have minus what? So this will give us what? 2 x exponent 4, and then we have y. Okay, yeah, from here, and then from here we have what? Minus 10, and then from here we have what? X. Okay, now let's take the second partial derivative. Okay, so we are trying to differentiate 2 times, so let's take the second one. So So the second one will give us what? 2 by 9, okay, that's what? 18x squared, and then you have y, then you have what? Minus c. So when you differentiate this, you end up with what? 2x exponent 4, and then we have what? This goes to 0, and then this goes to 0, okay? Right. You see how simple this is? It's very, very simple, okay? Very, very simple. Let's proceed to the next one, which is what? Partial derivative squared of what? Z, and then we have what? So we are trying to differentiate x and y, okay? X and y. So we have the third one, which is what? Squared z, okay? And then we are trying to differentiate x and y. So what this means is that we are just trying to do this, okay? This is what we are trying to do. Okay, so first we partially differentiate with respect to z with respect to y, x, and then after that we partially differentiate the zx with respect to y, okay? So the first step is to just partially differentiate the whole of this, okay? The whole of this expression with respect to z, okay? Which we initially did over here, and had what? 6xy cube minus what? 4x cube. Then we have what? Y squared plus y. And then the next step is to do what? We are trying to now differentiate or partially differentiate with respect to what? Y. Okay? Y. Now we are trying to, first we try differentiating or partially differentiating with respect to only x. Now we are trying to partially differentiate with respect to what? Y. Okay? So here, from here we have what? We have 18. Okay? We have 18 because this will multiply that. We have 18x y squared. Okay? And then from here, we have what? Minus what? 8. Okay? 8s cube y. And then this goes to what? 1. Okay? This goes to 1. See how then simple this is, okay? Very, very simple. So from here we are just done. Okay? We are done with the question. And then let's take a look at what's the fourth question. Okay, the fourth question. So we have what? The cube, okay? Cube. And then we are taking the partial derivative of y, z, y, and then z squared, okay? So we have the fourth one, partially differentiating with respect to z, and then we have what? Y, and then we are taking the z 2 times, okay? 2 times, okay? So let's take the exact question, okay? Right, so let me rewrite the exact question over here so that it becomes easier to, just have a look at it and then what? Solve it, okay? So from here, all we are trying to do is just first start from what? Okay, so I'm trying to rewrite the question, okay? Right, so let's do that. So we have what? The question is 3x squared y cube, okay? And then we have what? Minus x exponent 4 y exponent 2 minus 10y plus xy, okay? So just like here, okay? Right, so this is the main question. This is the main question, okay? This is the main question. Now let's start from what? So this is what we are doing. This implies that we are doing this, okay? We are first differentiating respect or partial differentiating respect to y, okay? So we have what? Y, x. This is what we are doing, okay? Keep that in mind. We are trying to just differentiate with respect to what? Or partially differentiate with respect to y, with respect to z, okay? So we try to partially differentiate z with respect to what? Y, and then x again. So you could just rewrite this as what? This way, okay? X, and then like this, okay? Or you could just rewrite that, okay, like this, okay? So we have y, and then we have what? Just squared, okay? That's all we are trying to do. Just try to partially differentiate, okay? So from here, let's start from what? We are trying to what? Partially differentiate with respect to y. So let's start from y. So we have what? From here, we have what? 9, okay? X squared. And then we have what? Y squared. And then when you move to this point, we have what? 2x exponent 4, and then we have what? Y, and then we have what? Minus 10, that's from here, and then we have what? X, okay, from here. Now let's proceed. So let's now take what? The second step, okay. The second step is what? We are trying to first take this portion, okay, this portion. After that, we take the entire of that portion of the what? The question. Now, so from here we have what? So for z, y, x, we are now trying to partially differentiate x, okay. We are trying to partially differentiate x with respect to y, okay. So we are taking the derivative of, or partial derivative of z, y, x, okay. So we have what? From here we have 18x, have y squared, then we have what? Minus what? From here we have what? 8x cubed y, this goes to 0, and then this goes to 1, okay. Now this is the final step, so we are now to take what? Okay, the entire of this, okay. Right, so that gives us what? 18, okay. So we are partially differentiating respect to what? X, okay. So this gives us what? 18y squared, and then we have what? Minus what? So from here we had what? 2, 4, 8. So we had what? 8s cubed. This is cube, okay. Let me rewrite that. This is cube. Okay, this is cube. So from here we have what? Minus 24 s squared y, okay, and then this goes to what? 0, okay. So this is the final answer for this question, okay. You could see how simple this is, okay. Very, very simple. And then you can just try working out the last question with me, okay. Just try work out the last question with me. So we have zxxy, okay. Let's see how you go by that. So that's the last question. So you have zxxy. Now let's look at the main question. Now this is the main question. So we are just differentiating from here, okay, partially differentiating from here, taking the partial derivative of z with respect to xxy. Okay, so let's first take the zx, okay. So when you take the zx, you end up with what? 6xy cubed. Then we have what? 4s cubed y squared, okay. And then this goes to 0, and then we have what? Plus y, okay. That's the first step. That's the first step. Now let's take what? zxx, okay. So for zxx, we are partially differentiating x again. So we have what? 6, okay. This will give us what? 6y cubed. Again, in case you've forgotten how to differentiate, okay, you could go back and then take a look at our video on differentiation, okay. After that you come back, or any video you could find differentiation. After that you just come back to this video and then proceed from there, okay. So we have what? From here we have this what? 12x squared, and then we have what? Y squared. So we don't have any x attached to this y, so that goes to what? 0, okay. So now let's take what? zx xy, okay. So we've moved from zx and then moved from zxx. So means we first took the partial derivative of z with respect to x, had this, and then took the second partial derivative of z with respect to x, and then we had what? This, okay. Right, now we are taking what? The partial derivative of z with respect to y from the same question, okay, and then from what we initially had. So we have what? We have 18, okay, 18y squared. Then we have what? Minus what? 24x squared y, okay. Right, so I hope this video was very, very helpful. And then in case you want to see more of these videos on this channel, all you have to do is just subscribe to the channel, turn on your post notifications, and then I will see you in the next video. Bye bye.